I'm Anil Kumar. Welcome to my series on parametric equations. In this video, we'll try to understand how to find derivatives when a parametric equation is given. In earlier videos, we discussed what parametric equations are and how to convert them to Cartesian form. Now, when you want to differentiate a parametric equation, then you don't really have to convert to Cartesian form. Differentiate really means we are trying to figure out what is dy dx, right? That is what we need to figure. The equation which I will be discussing with you is something like this. Differentiate each of the following and find slope at x equals to 1. That means we'll find the derivative and then we'll find its value when x is equal to 1, right? So this is what we are trying to calculate. For this, we have these 5 examples. So we have taken a linear function, reciprocal, well, that's also a linear function. And then we have different kinds of functions with, we've taken 2 with trigonometric functions. As you know, these will be circle and a parabola, right? Okay. Now, let's get into the business of differentiating these. Let me take the very first one to illustrate. So we are given x equals to 2 plus t. We could differentiate this with respect to the parameter t. So t is a variable, right? Now remember, in all these examples, t belongs to real numbers, right? When we talk about trigonometric functions, t is measured in radians. Okay, so dx dt is basically equals to derivative of 2 is 0 and that of t is 1, right? So we get 1. Now y is equal to 3 minus 2t dy dt is equal to, this is 0 and that is minus 2. So we do get dy dx by finding the ratio of these two, right? So we could do dy dt. Let me write like this: dy dt dt dx, or I could say dy dt over. So we could write this as dx dt, correct? Now in this case, dy dt is minus 2 and dx dt is 1. So we get our answer as minus 2. Now, it really doesn't matter for a line which point do you take. At all the values of x, slope is constant, right? So here, for part A, we find that slope is constant and is equal to minus 2, right? So that's what the slope is for part A. So here we did not even bother to find the value of t for which x is 1, since that was a linear function, correct? You could do the similar thing for part B also. However, in other questions, we'll have to find the value of t for which x is 1 and then get this derivative. Perfect. So now let's see how to solve part B, but we'll have a slightly different approach. That is, first we'll find the value of x, first we find the value of t for which x is 1 and then we'll continue, right? But overall, the method is going to be as discussed here. So I hope that is clear. You can also pause the video at this stage, solve the questions yourself, and then look into my suggestions. Now let's take part B. Now here we are given x is equals to t over 3, y equals to 2t. We need to differentiate this part with and find slope at x equals to 1. So let's look into this. We are given x equals to t over 3. Now if x is equal to 1, that means 1 is equals to t over 3, or 3 is equals to t. So basically, in this particular question, we need to find dy dx when x is equal to 1, or you can say t is equal to 3, correct? That is what the question is. Now, as we did earlier, let's differentiate both sides with respect to t and get our solution. So the idea here is that this derivative is equals to dy dt over dx dt, correct? So that is how we are going to get this derivative, and then we'll substitute the value of x as 1 or t as 3 to get our answer. Clear? So let's do the process. So on the right side of this, let's continue. So we are given x is equal to t over 3. So differentiating with respect to t, we get dx dt is equal to 1 over 3, right? As far as y is concerned, we know y is equals to 2t, dy dt is equal to 2. Right. Now, both are independent of t, right? So we don't have to bother about t value, correct? So now we can find what dy dx is. So dy dx is dy dt over dx dt. So in our case, dy dt is 2 and dx dt is 1 over 3. So we get this as equal to 6. So here, this is also a straight line whose slope is constant, and therefore we get this value as equal to 6, correct? Now it is not going to be the same for all other questions, right? Let's see how the things change when we work with part C, which is x equals to t cubed, y equals to 3 plus t squared. Right, so x is equal to 1, so we have x equals to t cubed. If I write x as 1, then t cubed is 1, or we can say t is 1, right? So basically, we're trying to find dy dx at x equals to 1 and t equals to 1. Clear? That is the concept, right? So let's find dx dt. We're given x equals to t cubed. Dx dt is equal to 3t squared. Now, we need to find what dx dt is when x equals to 1 or t equals to 1, correct? So if I substitute 1 here, I get 3 times 1, and this value is indeed 3, correct? Now we are given y equals to 3 plus t squared dy dt is basically, this is 0 derivative and this is 2t. So dy dt for x equals to 1 or t equals to 1 is 2 times 1, which is 2. Now this is dependent on t, right? So you have to find the value of t for which x is 1. Now we can say dy dx will be equal to dy dt divided by dx dt, correct? So in our case, we did find both at t equals to 1, or you could do like this also. You could write this as dy dt is 2t. You could do this also, alternate, right? Let's do this. You could do this, right? So you could say dy dt is 2t divided by dx dt, which is 3t squared, right? 3t squared. So you get 2 over 3t. And now you can say, well, dy dx is equals to, at t equals to 1 will be 2 over 3 times 1, which is 2 over 3, right? You could find like this. Or, as we did, you could also do like this, alternate. You can say dy dx at x equals to 1 and t equals to 1 is equal to dy dt at x equals to 1, t equals to 1 divided by dx dt at x equals to 1, t equals to 1. And then you have these values 2 and 3. So So we get 2 over 3 as our answer. Either way, you could do it. Perfect. Let's move on and take the next question. Now here we have trigonometric functions, and I hope you remember that the derivative of cos is minus sine x and derivative of sine x is minus cos x. With that in mind, I'd like you to pause the video, answer this question, and then look into my suggestions. Part D is we need to differentiate and find slope at x equals to 1. So let's find the value of t for which x is 1, right? So we are given x is equals to 2 cos t. If x is equal to 1, we get 1 equals to 2 cos t, or 1 over 2 is equal to cosine t. So as far as cos is concerned, we can say t is equal to cos inverse of half, right? So cos inverse of half means what angle we are talking about. Well, let's look into our special triangle where the sides are 1, 2 and square root of 3. So that gives you could do pi by 3 is your angle, correct? So we get t as equal to pi by 3, clear? So we get this value of t, right? Now let's do our derivative part. So we have x equals to 2 cos t dx dt is equal to, so derivative of cosine is minus sine, so I get minus 2 sine t. And now we can say dx dt at t equals to pi by 3 is what, right? So we'll write pi by 3 here. We get minus 2 sine pi by 3, correct? And the value is sine pi by 3 square root 3 over 2. So we get minus 2 times square root 3 over 2, which is minus square root 3, correct? So we get one part. Now let's find the value for dy dt. We have y equals to 1 minus sine t dy dt will be, this is 0 minus cos t. So dy dt for t equals to pi by 3 will be minus cos pi by 3, right? So minus cos pi by 3 is half. So we get this value as half, clear? Now let's write down our answer. So we need to find what is dy dx when x equals to 1, and we know x is 1 when t is pi by 3 or t equals to pi by 3. Is that clear to you? Correct? So that is, we have these two values right there. So we have dy dt over dx dt, and for both, when t equals to pi by 3, t equals to pi by 3, t equals to pi by 3, we have already calculated the values. So it's good to use these values, right? So we have minus half over minus square root 3. So we get minus minus cancel, 1 over 2 square root 3 as our answer. Perfect. Now this could be written as, we could rationalize, so we could also write this as 1 over 6 and then multiply by square root 3, right? So we could get this square root 3 over 6 as our answer. Is that clear to you? So now I'd like you to pause the video, look into this. We rationalized it, right? Basically multiplying by square root 3 and dividing by square root 3 gives you 3 times 2 as 6, square root 3 in the numerator. Perfect. Now let's take the last example, which is x equals to 1 plus cos 2t, y equals to minus 1 plus sine t. We are given x equals to 1. So if I substitute 1 here, we get 1 plus 1 cos 2t, that is 0 equals to cos 2t, and that tells you that 2t should be equal to what? 1 is cos 0, pi by 2, right? So from here, we get t equals to pi by 4. So when we are saying x equals to 1, we are also saying t is pi by 4. Is that clear to you? So now let's find dx dt and dy dt. So we have x equals to 1 plus cos 2t. Differentiating with respect to t, we get dx dt equals to, this is 0, that is minus 2 sine 2t, right? And dx dt, when x equals to 1, we found t is equals to pi by 4. So we'll write pi by 4 here, minus 2 sine 2 times pi by 4, correct? Which is minus 2 sine pi by 2. And for sine pi by 2 is actually 1. So we get this as minus 2, correct? So we get 1 value. Now let's differentiate y with respect to t. So we get dy dt equals to cos of t. Now dy dt for t equals to pi by 4 is equal to cos of pi by 4. Now cos of pi by 4 is 1 over square root 2, correct? So now we can find what is dy dx when x equals to 1 and t is pi by 4, right? So we have these two values, we'll take their ratios. So basically we have dy dt for t equals to pi by 4 over dx dt for t equals to pi by 4. Two values here are 1 over square root 2 divided by minus 2, right? So you could write this as minus 1 over 2 square root 2. Now when you rationalize, you get this as equal to minus square root 2. Square root 2 times square root 2 is 2, 2 times 2 is 4. So we get that as our answer. Is that clear to you, right? So we basically rationalize, and that is kind of important step. Many times in multiple choice questions, that will be your answer. Is that clear to you? So this is how we are going to solve this particular question. I hope the steps are absolutely clear and you have understood how to differentiate equations when we are given in parametric form, just as we did for all the 5 examples. Feel free to write a comment, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for watching and all the best.